In this video, we're going to look at conic sections, in particular parabolas. So the four conic sections that we have are circles, which is what you get when you intersect a cone with a flat horizontal plane. If you slant that plane just a little bit here, you get an ellipse, which is a special type of oval. And if you slice it vertically, you actually get two sides to this particular shape called a hyperbola. Those will be in later videos, but in this video, we are going to look at what is a parabola by the geometric definition, and we'll derive where the formula comes from. So this is a little bit different than your approach you might take in, say, an algebra class. The geometric definition of a parabola, it is geometrically, it's the set of all the points that are equidistant from a point, which we call the focus, and a line, which we call the directrix. So you have a line right here and a point. And if you say, okay, what are all the points? This is the red parabola, right? What are all the points where if we have a pen, let's say, and maybe even like a string, you can think of this as a string, that distance, the distance from there to this focus, which is an invisible point, right? We don't really draw it usually on a parabola, but the distance from that point, you can think of it as like a nail, right? And you've got a string from that nail to here, and then the string from here to a line, that distance is the same. So this distance, put 3 marks, is equal to that distance. And it doesn't matter what point you pick on the parabola. Here's another one there. It's marked with the double lines. That distance is equal to that distance. Or if you're right here, right, this distance equals that distance. The distance from this imaginary point called the focus to this invisible line, I shouldn't say imaginary, but invisible line, which we call the directrix, those distances are equal. And specifically, this distance right here from the focus to the vertex, that's the V vertex of the parabola, is equal to the distance from the vertex down to that directrix, which has a special name, which we'll talk about in just a moment. So the focus we're calling F, the line that is a little lowercase l, we call that the directrix, okay? So let's look at what is the geometric equation for a parabola. Now this equation is only going to be true for parabolas centered at 0, 0. If they are shifted, it changes just a little bit, and that's a little bit more of an advanced topic. So if P of xy is any point on the parabola, that's this point right here, just any random point on a parabola. Okay, then the distance from P to the focus right there, by the distance formula, we're going to use the coordinates. Now, what we are doing is we're going to call the focus, we're going to let that be the point 0, comma P. So P is just some number that we're trying to relate P with the equation of the parabola right now. That's what we're trying to do. So if we let P be the distance, little p be the distance from the vertex to the focus, then the focus, if the parabola opens up, is at the point 0, comma p, and any random point in the parabola we call xy. So the distance between them by the distance formula is equal to the square root of the distance between the x's is x minus 0, all squared, or just x squared, plus the distance between the y's is the y coordinate here minus the y coordinate there, all squared. So y minus p, all squared. So that's the distance here, okay? Now, by the definition of a parabola, that distance is equal to this distance, and the distance from there to there, that directrix there, right, from P, which is x comma y, to that, that is equal to this y value, which is at the distance from here to here, that's y, plus the distance from here to here is also p, because these distances are equal. So if the distance from the vertex to the focus we call little p, then the distance from the vertex to the directrix is also little p. So therefore, let's clean this up a little bit here, right? So therefore, the distance from all the way from p to this line is that sum of that distance, which we call y, plus this distance, which we call p. So that distance done that way is equal to, we'll use absolute value bars just to make sure that it is positive, but it is equal to y plus p, because your y value could, of course, be negative, right? So if we set those equal to each other, we know those distances are equal because that's the definition of a parabola. So we can set those two things equal and say, okay, by the definition of a parabola, then the square root of x squared plus y minus p all squared is equal to the absolute value of y plus p. So what we're going to do is simplify this a little bit to derive the equation of the parabola, to relate the little p, the distance from the vertex to the focus, to the standard equation that you're probably used to from algebra class, okay? So to simplify this, what we're going to do is square both sides. That's going to get rid of the square on that side. And at first it looks a little bit weird on the right because we are squaring an absolute value, but that actually makes it easier because if you square something, it's going to be positive anyway. So that allows us to just convert those absolute value bars into parentheses. So y plus p all squared then is equal to x squared plus y minus p all squared. And so we need to do a little bit of algebraic manipulation here. We're going to give ourselves a little more room there. All right, so what we're going to do is expand this and this by foiling that out. So we're over here on the left, we're going to have x squared plus. Now, if I FOIL out y minus p, that's y minus p times y minus p, we will get y squared. Then minus yp is going to be minus 2yp. Negative p times negative p is positive p squared. And we're also going to FOIL on the right. So y times y is y squared, plus the outer and inner terms add to positive 2yp this time. And then p times p is positive p squared. Now we want to simplify this just a little bit so we can subtract p squared from both sides. That just cancels. And we can also just subtract the y squared from both sides, and that just cancels. And this simplifies down to, so far we've got x squared then minus 2yp is equal to 2yp. So what I can do is add that 2yp to both sides. And that gives us x squared is equal to 2yp plus 2yp makes 4yp. And that is the derivation of the standard equation of a hyperbola that opens up in terms of p. So p is that distance from the vertex to the focus, or equivalently right here, or equivalently the distance from the vertex to the directrix, which are both invisible lines. We don't typically plot those points, right? Or those distances, or not focus and directrix. We don't usually plot that when we're plotting parabolas, right? But that is the geometric definition of a parabola. So that is the standard equation of a parabola with a vertical axis with the vertex at the origin. If the p is positive, it opens up. If p is negative, it will open down. And if x is replaced by negative x, that would make it symmetric, but this way it wouldn't change anything. All right, in future videos, we will study more about the different ways a parabola can open and how these equations can be manipulated.